Hello and welcome to my channel once again. Today we have another exciting math tutorial for you. And it is that 3 minus k, 6 and 7 minus 5k, if it's a geometric sequence, then we want to find two possible values for the constant k, the common ratio of the sequence, and the sum of the sequence. Sit back, relax, and enjoy the tutorial as we bring it to you. Now to solve this, we know that for a geometric sequence, the ratio of the second term to that of the first term is the common ratio, which is also the ratio of the third term to that of the second term. In short, the common ratio is the ratio of successive terms. Therefore, in this sequence, the common ratio is 6 over 3 minus k, that's the second term to the first term, which is also equal to 7 minus 5k over 6, the ratio of the third term to the second term. Then we take the cross product, which is 36 for 6 times 6, and for the other binomials, it is 3 minus k times 7 minus 5k. Then we distribute 3 minus k to 7 minus 5k on the right side, where we have 36 equals to 21 minus 15k minus 7k plus 5k squared. We subtract 36 from both sides and arrange the like terms, so that there is 0 here. On the left we have 21 minus 36, then minus 15k minus 7k gives minus 22k n plus 5k squared. And this we try to rearrange, starting with the highest power in k, that's 5k squared, minus 22k minus 15 for 21 minus 36, and that's equal to 0. Then we look at factoring the quadratic equation, where the product of the first and the third term are negative 75k squared, with the factors to consider being negative 25k and positive 3k. That is, the product of negative 25k and positive 3k gives negative 75k squared, and when added together, they give negative 22k. So that the expression on the left hand side can be broken down into 5k squared minus 25k plus 3k minus 15 equals to 0. Grouping in twos, from the first two groups, 5k squared minus 25k, we can factor 5k, and in parentheses we'll be left with k minus 5. Then from the second group, 3k minus 15, we can factor 3, positive 3. Also left in parentheses is k minus 5, and that's equal to 0. So k minus 5, being the common factor, is factored out, and that's multiplying 5k plus 3 equals to 0. And by the zero product property, k minus 5 is either 0 or 5k plus 3 is equal to 0. Then solving each of them for k, we have that k is equal to 5 when we add 5 to both sides, or 5k is equal to negative 3. So k is either 5 or k is just negative 3 over 5. These are the two possible values for k. In the second question, we have to find two possible values for the common ratio. And this is the second term, 6 over the first term, 3 minus k, which can also be the third term to the second term. Now, we consider when k is 5. When k is 5, the common ratio will be 6 divided by 3 minus 5, and that is 6 divided by negative 2. Negative 3 is the value of the common ratio when k is 5. Also, when k is negative 3 over 5, we have that the common ratio is 6 divided by 3 minus negative 3 over 5. This is 6 divided by the sum of 3 and 3 over 5. Simplifying further, this gives 6 as the numerator divided by the sum of 3 and 3 over 5, which is 18 over 5. That becomes 6 times 5 over 18, and 6 times 5 over 18 is 5 over 3. So the two possible values for the common ratio would be negative 3 or positive 5 over 3. Then the last question requires that we find two possible values for the sum of this GP. To find the sum of the sequence, we need to know the three terms of the sequence. And this we do considering the different values that we add for k. So we start with when k is 5 and we make the list of the sequence. Now when k is 5, the first term, 3 minus k, is going to be 3 minus 5, comma, the second term, which is 6, and the third term, which is 7 minus 5 times 5. Making the list to be negative 2, 6, and 7 minus 25, which is negative 18, where the common ratio is negative 3. The sum of the series in this regard, with the common ratio being negative, is the first term times 1 minus r to the power of n, the number of terms, over 1 minus r, giving the sum of the three terms as negative 2, the first term, times 1 minus the common ratio, which is negative 3, to the third power, being the number of terms that we have, over 1 minus negative 3. This is negative 2 times 1 minus negative 3 to the third power is negative 27 over 1 plus 3 in the denominator. This is negative 2 times 28 for 1 minus negative 27 over 4. And 4 we go into 28 7 times, which means that the sum is negative 14. So to get the second possible sum for the sequence, we find the list. We made a list of the sequence when k is negative 3 over 5. Now when k is negative 3 over 5, the first term, which is 3 minus k, will be 3 minus negative 3 over 5. The second term is still 6, and the third term will be 7 minus 5k. That's 7 minus 5 times negative 3 over 5. So the first term will be the sum of 3 and 3 over 5, which is 18 over 5. the second term 6, and the third term is 10. These are the three terms. And the sum in this regard, with R being 5/3, we use Sn is equal to A times R raised to power n minus 1 over R minus 1, making the sum S3 to be 18/5 for the first term times 5/3 for the common ratio to the power of 3 minus 1 over 5/3 minus 1. This is 18/5 times 125/27 minus 1 divided by 2/3. Simplifying this further is 18/5 times 98/27 divided by 2/3, which simplifies to 18/5 times 98/27 times 3/2. And this, when reduced further, is 98/5. We can therefore conclude that the two possible values for K are 5 and -3/5. The two possible values for the common ratio are -3 and 5/3, while the two possible values of the sum of the sequence will be -14 and 98/5. I believe you enjoyed today's tutorial. Please let me know in the comment section. Don't forget to like and share this video. Your questions, comments, please send them to the comment section or to the email in the description box. If you are yet to subscribe to my channel, kindly click on the subscribe button now and the notification bell so that you do not miss out on any updates from this channel. Thank you for watching this video. See you in my next video. Bye.